So first, let me start off with, I sent an announcement in Canvas, and I want to apologize in person. I posted quarter grades without your 2D motion test being part of your quarter grade in Canvas. It was in a category, it was worth 0, I screwed up. I've since moved it into the category, the standard that it should. Your grade in Canvas is what your quarter grade really is. Okay, so if you saw that grade published in Infinite Campus, it is not an accurate grade at this point in time. What is posted in Canvas is really the grade, that it should be. I talked to Mrs. Barwick after school. She said we can still fix it, so my plan is to change them to reflect what it is in Canvas. So just so you know, the grade that you maybe got the notification was posted in Infinite Campus is not truly your grade at the quarter, because I didn't have your 2D motion grade factored in. They were in, but they weren't weighted at all. So, sorry, I'm gonna fix it. Realize that grade is gonna change in about 40 minutes from now. And it'll reflect what's in Canvas. All right, so let's take a look at in-class Unit 4. I wanna talk briefly about number 4, and then we're gonna do number 5 together. So question number 4 on in-class Unit 4, that's the name of the worksheet, says find the normal force acting on a 2 kilogram block sitting on a table. So if I have a 2 kilogram block sitting on a table, here's my block, here's my table, what forces are acting on that block?
Normal and gravity.
Normal and gravity, right? If it's sitting on a block, what's true about the velocity? If it's sitting on a table, what's true about the velocity? Constant and changing.
Constant.
And my acceleration is?
0.
So my forces are? Balanced. Okay, so how do we calculate force of gravity? Force of gravity is equal to weight, which is equal to m times g. So what's the m in question number 4? 2. So we take 2 times 9.8, and that gives us a number. I think it's 19.6. I don't care. Yeah, it is. It's 19.6. So if my force of gravity is 19.6 down, and my forces are balanced, what does my normal up have to be? 19.6. Good. Because my force is balanced, there's 1 up, 1 down, they're going to be the same. Now let's take a look at number 5. I've referenced number 5, I kind of talked about it a little bit yesterday, from like, oh, if my computer weighs 10 pounds, it's kind of one of those problems. So for problem number 5, this is the calculation we're going to go through. Find the normal force acting on a 15 kilogram block that is sitting on a table and is being pulled upwards with a 60 Newton force. So here's my 15 kilogram block. What forces are acting on my box?
Gravity.
We have a force of gravity.
Normal.
We have a normal force, perhaps. Actually, here, let's go like this quick. Yes, there's a normal force. How do we know? Because it says, what is the normal force? Okay, well, let's stop here for a second. Force of gravity. If there's a force of gravity, if an object has mass and is in a gravitational field, then it's going to have a force of gravity. So force of gravity is equal to weight, which is equal to m times g. And then this is 15. Our gravitational acceleration on Earth is 9.8, which gives us a number, I think it was 15 times, of 147 newtons. So what is the force of gravity of this object? 147 newtons. What is the weight of this object? 147 newtons, right? Because force of gravity and weight equal each other. It's the exact same thing. What is the mass of this object? 15 kilograms. Okay, 15 kilograms. What is the gravitational acceleration on Earth? 9.8. That's g. So here is our force of gravity. Now, normal forces mentioned, yes, there is. Let's come back to that in a second. Are there any other forces acting on this object?
Applied.
There's an applied force. Do we know the value of that?
Yeah.
What is it? Is it
60?
60? Okay. So if a thing weighs 147 newtons, and I lift up at 60 newtons, do I move it?
No.
No, it's still going to be sitting on the surface, right? So if it's still sitting on the surface, Is there a normal force? Yes, okay? That's why there's a normal force. Because I didn't lift up high or strong enough, I'm not strong enough, to actually pick this 147 Newton thing up. I didn't apply big enough force. So there is going to be a normal force. That's ultimately what we're trying to figure out in this particular problem. Now, if it's sitting on a surface, or if the object's there and I pull up at 60 newtons, what's true about the velocity? Constant or changing?
Constant.
Yep, one of those two. Which one is it? Let's say I weigh 147 pounds. You come up and you can only lift up at 60 pounds. Did my velocity change?
No.
Did I move?
No.
So what's my velocity? Constant or changing?
Constant.
So what's true about my acceleration?
0.
So my F net is,
0.
and my forces are,
Balanced.
they're balanced, right? And that's all kind of coming off of this intro to forces sheet. So, also referencing this sheet, there was 3 forces that we highlighted that have their own equations. One of them is force of gravity, there's the equation. The other 2 we haven't talked about yet. These 2 equations, F of g is equal to weight, which is equal to m times g, and Newton's second law, sum of all my force equal to F net, which is equal to mass times acceleration, are the only 2 equations we really have at this point. If it doesn't have its own special equation, then we have to use Newton's second law. Newton's second law says the sum of all my forces is equal to F net, which is equal to mass times the acceleration of that object. And we said my F net was 0, or you could say we said our acceleration is 0. This piece right here is when I talk about forces, the sum of all my forces, in the x direction we add our rights, we subtract our lefts, in the y direction we add our ups and we subtract our downs. And I overheard some conversations yesterday during the quiz, during homework, and some students are like, I don't understand that. So I want to make sure I'm emphasizing or reinforcing it. What it means when I add my ups is I add all of my forces that have an arrow pointing upwards. It's just a generic way of me saying add my ups, is adding my forces that are pointing in the upward direction. That's really what I'm saying. And I subtract my forces that are pointed in the downward direction. To be lazy, add my ups, subtract my downs. But it's all of my ups and subtract all of my downs. So I have to add any force that's pointing upwards. So if I look at my free body diagram, by name, what forces are pointing upwards?
Applied force.
I have an applied force, up, yep. Do I have any others?
Normal.
I have a normal that's also pointing upwards. Are there any other upwards? No. So then I subtract my downs. What forces are pointing down?
FG.
F of G. Are there any other pointing down? No. And then we set that equal to F net or m times a. It doesn't matter in this situation because they all add up. That they're all equal to 0. Now, this is 0 because this was 0, is really where that comes from. I really encourage you to do it by name first, before you get too excited and put numbers in. Now that we have Newton's second law, what this is really saying is all of my ups, my 2 ups, minus my downs have to add up to 0 because it's not moving. So I have to add 60. I have to add F of n, but I don't know my normal force. That's what we're trying to figure out. And if we subtract our force of gravity, those have to add up to 0. So 60 plus blank minus 147 is 0. Or we do some algebra. It depends on how you want to figure this out. There's a couple different algebraic ways you can do it. But what we find is our normal force is equal to 87 newtons. 87 plus 60 minus 147 have to add up to 0 because my forces are balanced. Now, in a different situation where there was an acceleration, then we'd add our ups, subtract our downs, and set it equal to m times a, and whatever m times a is what my unbalanced forces are. Okay? Most of the time, when we talk about normal force, it's like problem number 4. Most of the time, there's a normal force up, and there's a gravitational force down, and the forces are balanced. Most of the time, your normal force and gravitational force are the same. But it's not always going to be that way. It's not always that way. It could be something like this. So why would this happen? I don't know. I'm trying to lift something up and I'm not strong enough. What happens in a little bit is when we start talking about friction, if this object is sitting, if my normal force were all of 147 and I try to slide this across the ground, my force of friction becomes much larger. But if I lift upwards on it while I try to slide it across the floor, I didn't say pick it up, I said lift upwards on it, then we have a smaller force of friction. But we'd also have to have another applied force. So it's a different free body diagram, but this is something to keep. All right, I got some sheets. I don't know where my sheets are.